Hello friends, welcome back to my channel. Today we are going to study about a topic in inorganic chemistry, chemical periodicity. This topic can be seen in so many places, include chemistry in plus 2 and some entrance examinations and also even syllabus in the net. So in chemical periodicity, the first topic is classification of elements. So we know that today's periodic table there are a lot of elements. So these are elements, how they arrange in a perfect manner, that is the classification of elements. The first classification of elements is Proud's hypothesis. This is the first theorem, and it was made in 1850. So in this theorem, also called unitary theory. So this theory, hydrogen atom considered as a fundamental unit. This is the smallest theory. Not need to study more about this. Okay. The second one is Dobereiner's triads, and this was made in 1829. What is triads? Triads means 3. So he classified the elements into group of 3 with similar properties. So he classified the elements with their atomic weight. So he classified the 3 elements in a group, and he thought that the atomic weight of the middle one element is the arithmetic mean of other 2. For example, he classified lithium, sodium and potassium in a group. In this group, lithium atomic weight is 7 and potassium is 39. So what we get? 7 plus 39 by 2. Arithmetic mean means by 2 is equal to 23. This is the exact atomic weight of the sodium. So he thought that the elements we can classify the non-element, and that time the non-element into 3 group of 3. And also he classified basis of this theorem in chlorine, bromine and iodine. This is the second group. And calcium, strontium and barium. So he classified the non-element into 3 group, which is one group containing lithium, sodium and potassium. The other group, second group is chlorine, bromine and iodine. And the third group is calcium, strontium and barium. But this theorem has some limitations. The first limitation is he could not arrange the all elements known at that time into triads, but because he couldn't arrange the whole elements at that time non-elements into these 3 triads. So he failed to organize the other elements. The second one is only identify 3 such triads. So due to this limitations, his theorem was neglected. So the next theorem is Newland's octaves, and this theorem was made in 1861. And also this theorem is also called law of octaves. What is octave? Octave means 8. So you already got the clue. So he stated that when elements are arranged in order of increasing atomic masses, every 8 element has properties similar to first. So that is why this law is called law of octaves. So he said that the atomic number of each elements after 8 have the same property of the first one. So we can for example, lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. and sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, potassium, calcium. So here the lithium is the first one, then second, third, fourth, fifth, sixth, seventh. After seventh, who came? Sodium. So 1 and 8, lithium and sodium have the similar properties, not same property but have similar properties. And also beryllium to magnesium, boron to aluminium, carbon to silicon, nitrogen to phosphorus, oxygen to sulfur, and fluorine to chlorine have the similar properties. So what he find out that every light element is the repetition of the properties. So here lithium, sodium, and he arranged these octaves, and unfortunately this theorem have the limitations. And what are the limitations of this octave theory? In this theory, this classification only applicable up to calcium. So he also failed to arrange or failed to apply this octave theory to after calcium. And when noble gas elements are discovered at later stage, octaves rule disturbed the entire arrangement. So when the octave theory or octave law, that time of octave law, in that time only noble gas didn't found. So after the discovery of the noble gases, this octave theory is disturbed. So because of these limitations, this theory also failed. Then the next theorem is, the fourth theorem is Lothar-Meyer's atomic volume curve, and this theory was made in 1869. And in this model, elements are classified in the form of curve between atomic volume and the atomic mass. So here he not only considered the atomic mass but also considered the atomic volume and atomic masses. So he take the both atomic volume and atomic mass of each elements, and he draw a curve of each elements, and through this in this curve he classified the elements. Also, their properties are the periodic functions of their atomic volume, and he also find out that the property means the atomic function, the periodic functions of the atomic volume. So what is atomic volume? Atomic volume means the molecular mass by density. Molecular mass by density. Molecular mass of the element by density of that element is the atomic volume. So he find that the atomic volume is the reason of the properties. So he concluded that elements with similar properties occupy similar positions in the curve. So here is the atomic volume in the y-axis and atomic mass in the x-axis. And he take the atomic mass and atomic volume of the each elements, and he draw a curve, and he just unite the each elements position, and he got a curve. In this curve, the upper position of this curve have the similar properties, and the middle have similar properties, and below have the similar properties. So he found that lithium, sodium, potassium, rubidium, cesium have the same property, and shown. And these models have also some limitations, so this theorem also failed. The next theorem is Mendeleev's periodic table, and this theorem is based on the periodic law. And what is periodic law? And they state that physical and chemical property of an element are a periodic function of their atomic masses. What he say? The physical and chemical property of an element are the periodic function of their atomic masses. In the previous theorem, he said that the periodic function of the atomic volume. But here, Mendeleev state that the physical and chemical properties are the periodic functions of the atomic masses. So he changed the atomic volume into atomic masses. So what happened means periodic functions means certain properties repeat after certain periods. So today we know that alkaline metals, noble gases, they have also their similar properties. So that is periodic functions. Certain properties repeat after certain periods. In that time only 63 elements were known. So he classified the 63 elements into 8 groups and 7 periods. And later he added the 0 groups. Zero groups also called noble gas elements. Okay. So next one is the importance of this law. And here in this Mendeleev, he studied all elements in systematically, and also he left space for elements that not discovered yet. For example, that time gallium and germanium. Later we found gallium and germanium. In that time Mendeleev named gallium, and give a empty space for these both elements. And he named gallium as the Eka aluminium and germanium as Eka silicon. That time aluminium and silicon are invented or discovered. So he give a space and named as later it would be another element will discovered, and he gave the name that Eka aluminium and Eka silicon. So this is due to systemic study of each elements. And also, like other theorem, this theorem have had also some limitations. The first one is the position of hydrogen, because hydrogen at that time hydrogen has both property of alkaline metals and halogens, but he placed hydrogen on the group 1. So hydrogen show the alkaline properties and halogen properties, but the question is why he placed the hydrogen into the alkaline metal group or group 1. So that's a questionable in that time. And the position of isotopes. We know that what is isotopes? Isotopes have the same atomic number but different mass number. So here he classified the elements in the basis of the atomic masses. So due to this different mass number, it would be placed in the different positions. But he placed but he didn't mention anywhere about the hydrogen isotope.